All right, this video is going to go over the test review for test 3B. It's going to be a long video, so if you know something pretty well and you don't need help with that, just fast forward and jump to the spots that you do need help with. But let's go ahead and get started. The first part is about graphing inequalities. Remember, if it has the or equal to sign, it is a solid line. If it does not have the or equal to sign, like this one does not, it is a dotted line. So that's the first thing to realize. Points on solid lines are good. Points on dotted lines are no good. They don't be included. So keep that in mind. And then lastly, less than symbols shade below the line, greater than symbols shade above the line. So that's how I'm going to do all these. You just really need to know how to graph lines in general. So start at your y-intercept, which is +8. You're going to put a dot there. And then the number by the x tells you your slope. So like this one's -4/1. That means drop 4 and run 1. And I always run to the right. So this line, put a couple of dots down, it would look something like this. It is a solid line because it has that or equal to. So there's my first line. The second line is a dotted line starting at a y-intercept of 4, slope of 2, so rise 2, run 1. Now make it a dotted line. It would look something like this. And then in terms of shading, this first one's everything less than, that's everything below. And then the second one's less than as well, so that's below. So the part that they both share is this part right here. And so the point that's a solution to that, 1, -3 is right here. That works. -2, 0 is on a dotted line. That does not work. -4, 6 isn't even close. And 6, -2, that's not close either. So my answer is A. Okay, let's look at the next one. Graph this equation. Start your y-intercept. Drop 5, run 3. This is a solid line. So it looks something like this. The second line, you need to convert it to mx plus b form, so -4. So now it's y is less than 3x minus 4. So it's a dotted line, y-intercept of -4. Rise 3, run 1. Make it dotted. All right, now the shading. It's everything greater than the blue line, so everything above the blue line, and then everything below the orange line. So above the blue line and below the orange line would be this section right here. So what's a solution to that? Well, 4, 1 is right here. Oh, they're asking for not a solution. So 4, 1 is a solution. 2, 2 is on a dotted line. That is not included. So that's probably my answer. But I'm going to look at the others anyways. 7, 0, that's in the section that's shaded. And then 3, 4 is right here. I think that's included. So my answer here would be B, 2, 2. All right, this next one, they're going to change it up a little bit because now they're going to give you absolute value. Go get the vertex. The vertex is at 3, -2. That's here. Then this is a negative absolute value, this negative sign in front. So absolute value, first of all, is a V shape. And the negative just turns it upside down like this. So it's a downward opening. Each one of these has like a slope of -1. You could kind of think of it like that. So it would look like this and like this. All right. And it was a solid line because of the or equal to. And then there's another line, y is greater than or equal to -5. That's just a horizontal line at -5 like this. So Now, in terms of shading, it's everything below, less than, below the blue line and above the orange line. So that's this section right here, this little triangle. And so in terms of answering this, 3 2s up here, no. 0 -4 is here, no. 3 -2 is here. That's on a solid line, so it's good. 4 -7, that's too low. So my answer is C. All right, moving right along. This next one's another absolute value. Get your vertex of -3, -3, and put a dot there. Now, this one's a V shape going up with a slope of 2. So rise 2, run 1, either direction forever is basically what it's telling you to do, like this. This is a solid line. So it looks something like this. Then the second line, you need to get it to mx plus b form, so -2. So it's going to look like y is everything less than -x minus 2. Start at your y-intercept, and you're just dropping 1, running 1. And this is a dotted line, so I'm just going to leave it as these dots, like this. Okay. Now, in terms of shading, it's everything greater than the blue and less than the orange. Well, that's this section right here. So which point is not a solution? So -4, 2 is here. That's on a dotted line. That's no good. That's probably my answer. -2, -1 is on a solid line, so it's okay. -3, 0 is in the green, so it's okay. And -6, 3 looks like it's on a solid line as well. So my answer is A. Okay, moving on. These, now they're going to give you quadratics. So it's not a V shape, it's more of a U shape. But stick to the plan. Go get your vertex. -2, -6 is here. Now this is just a regular quadratic with an a value of 1. So you have these next two dots if you want them, but you're missing this dot right here, right? So that's at an x value of 0. I'm just plugging in a 0 here to find out where it is. So at an x value of 0, plug it in. 0 plus 2 is 2, squared 4, minus 6 is -2. Now I've got that dot, and it's a mirror image on the other side. This is a solid line, so it looks something like this. All right, next is you need to convert this to mx plus b, so subtract the x. You would get less than -x minus 6. So that's here with a slope of -1. Okay, and it's a dotted line, so I'm just going to leave it as those dots. Now, in terms of shading, you want everything greater than the blue, but less than the orange. That's this section right here. So the point that's there, -3, -2 is right here. That's just outside. -2, -2 is here. That's outside. -1, -1, that's right here. That's outside. -2, -5 is here. That's inside. That's my answer. All right, this next one. This is a quadratic again. So go get your vertex of 3, 4, and put a dot there. Now the a value is -1. So what that means is these next two dots, you have them, but they're below. Now you're gonna need the next dot. It's like somewhere right here, right? That's at an x value of 1. So just go plug in a 1 here. 1 minus 3 is -2. Squared is 4. Now it's -4. Plus 4 is 0. So it's here. And then it's a mirror image on the other side. So this one is a dotted line, so it looks something like this. All right. The next one is going to be convert it first of all, so it's less than or equal to 2x minus 5. Start at your y-intercept of -5. Now you're rising 2, running 1. Like this. And it's a solid line. Now, in terms of shading, it's everything less than the blue and less than the orange. So that's going to be okay. We had like a jump there. Sorry about that. That's going to be all of this section right here. So, which is not a solution, is 5, 0 is right there on a dotted line. That is not a solution. That's probably my answer, but I'm going to check the others anyways. 3, 0 is good. 4, -4 is good. And 2, -6 is good. So yeah, it was that first answer. Okay, now they're going to give you some that have 3 lines. Same thing though. Start with your y-intercept. So like this one, I'd start with that -1. Rise 3, run 2. This is going to be a dotted line. I'm going to try to be accurate on this. I feel like it could get messy. Okay. So here's the first line. The second line, y is less than 4. Is a dotted line just horizontal at 4? And then this third line, make it into mx plus b. So subtract 3. So you got y is greater than or equal to -2x minus 3. Y-intercept of -3. Now you drop 2, run 1. And this is going to be a solid line. All right. Now the shading on these can get pretty tricky. It's everything above the blue, so above the blue, below the orange, so it's already restricted to just this section, but then also above the pink. It's this triangle in the middle. Now, check your points, which is a solution. -6, 0, no. 2, 2, that's on a dotted line, no. 0, 1, yes. 0, 4, it's on a dotted line, no. So that's how you would do that one. Okay, this next one, same thing. Convert that equation first thing. So y is greater than or equal to -4/3 x minus 5. Start your y-intercept. You're dropping 4, running 3. So this first one's off the graph there. That's okay though. Work your way back. I think it's here. It's hard to see. All right, this is a solid line. Looks like this. All right, this next one. It's ready to go. Just start your y-intercept of 6, and then it's a slope of 1 as a dotted line. I need to put some dots there. It's kind of hard to see because these graphs are so small. Okay, now the third line, you're going to need to subtract 4x. So it's like y is less than or equal to -4x. Let me just rewrite it. -4x plus 2. So drop 4, run 1, and this is a solid line. So it looks something like this. All right, now in terms of, I did that the wrong color, didn't I? Let's make it look nice. Okay, now in terms of shading, it's going to be everything above the blue, greater than the blue line. So that's already all this. Less than the orange, so that's now this. And less than the pink, which is written in green, but that's okay. So it narrows it down to be this little triangle here. All right. Which of the following is not a solution? 0, 2 is on a solid line. It is a solution. Negative 2, 1 is in the middle of that triangle. It is a solution. 0, negative 5 is on a solid line. It is a solution. Negative 3, 3 is on a dotted line. That's the one that does not belong. Okay. That is how you do graphing inequalities. Now, these next ones are system of equations, and these can get really rough. You basically, if they give you something like this, like x equals 1, thank them because they just gave you a present. And so if they give you this, you just go plug it in and work your way up the staircase. So it looks like this: 3 times 1 minus 3y equals negative 6. Go solve this. Divide. So now I know x is 1 and I know y is 3. So now I can plug it in to the top equation for my x and my y and go solve for z. So that's like negative 4 times x plus 5 times y plus z equals 8. And just go solve it. Minus 11. Once you have your answer, it's written as an x, y, z coordinate. So this one would be 1, 3, negative 3. Just like that. So if they give you a letter on a system of 3 equations, you owe them a favor because that is a huge piece of information. Like this one, I can just divide by 3 right from the start and get x equals negative 2. This makes my life so much easier when I'm solving this because now all I do is I go plug it in for x here and just go solve that one. So add 2, divide by 3. Okay, and now I go and do the same thing, but I plug it in for x and for y into the top equation. So it's like 4 times negative 2 minus 3 times negative 5 plus 6z equals 25. Work this out. Subtract 7. Divide by 6. Once I know all my letters, I write them as an x, y, z coordinate. Just like that. Okay, 2 more pages to go. Now we're on number 11 and 12. These are more realistic system of 3 examples. And the reason is because they're not just giving you x equals whatever. So when you do these, you want to pick a number or a letter to eliminate twice. So when I approach this, I look at this right here. I'm seeing minus 5, plus 5. I could eliminate the letter y real easily. First of all, let me call these equations A, B, C. I could eliminate the letter y by doing like a plus c. That'd look like this. So this one's actually going to be kind of nice because the x's eliminate as well as the y's, and it just leaves you with negative 6z equals negative 18. Then you can divide by negative 6 and get z equals 3. That's a big piece of information. But you still have to stick to the plan. The plan was to eliminate the letter y twice. So we did so by doing a plus c. Now we're going to do so again by doing like b plus c. That would look like this. Okay. Now, usually you would have to go vertical here and eliminate another letter. But since we already know z equals 3, I'm just going to plug in z equals 3 right here and go get x. And once I know two letters, I can go back to any of these original equations and plug in the letters I know and go solve for the one I don't. So here's what I mean. Be like this. Then just go solve that. This negative here just turns into a positive 2. Divide by -5 and you get -3 for your y. So your answer is written as an x, y, z coordinate. So it'd be -2, -3, 3. Just like that. All right. This next one, pick a letter to eliminate twice. So like I'm looking at this again and I'm seeing the y's again because they're all pluses or minuses on the 4y. You could just add them together real easily and eliminate them. So label these A, B, C. All right, the way I'm going to eliminate the letter y the first time is A plus B. So it'd look like this. Okay, and then the way that I'm going to eliminate them again is I'm going to do A plus C. So it'd look like this. Okay, this is a more realistic problem because we still don't know any of these letters. So when this happens, you take them both vertical. It doesn't matter which one you write on top. So just write them on top of each other. All right, now you need to do elimination one more time. So like I'm looking at this right here thinking, oh, okay, if I just made this say plus 4z and then added them together, it would work. So I'm going to times this top equation by 2. Then add it to that same second equation, hasn't changed at all. When you do this, you'll get 21x, the z's cancel, equals 84. Then you divide by 21 and you get x equals 4. Once you know one letter, you work your way back up the staircase. And so you're going to plug it in. It doesn't matter which one of, you could either plug it in here or here. Either one of those is fine. I'm just going to plug it in right here to the one on the left. So it'd look like this. Then just go solve it. Divide by 2. Z is 0. Once I know that, I can take any of these original equations. I'm just going to take this first one and plug in both letters that I know and solve for the one I don't. So it look like this. 4x plus 4y plus z equals 24. Now just go solve. Subtract 16. Divide by 4. Now I know all my letters, and I write it as an x, y, z coordinate. All right, now on to the Gaussian elimination. So they're going to give you a matrix or two equations that you make your own matrix with, and you want it to say 1, 0, 0, 1. However you can make that happen, that's what you want it to say. So like the first thing you want to get is this 1. I'm going to do that by, this is row 1, this is row 2. I'm going to do row 1 divided by 5 and rewrite it in the row 1 spot. So that would look like this. Now row 2 did not change. Let me do that in a different color. Okay, row 2 did not change. All right, the next thing I'm going to do is I need to get this 3 right here. I need that to be a 0. So I'm going to do, what if this said -3 right here? Then I could just add it, right? So it's row 3 times row 1, then added to row 2, and I write it in the row 2 spot. So that's going to look like this. 3 times, I'm going to do it off to the side. 3 times row 1 would be 3, 6, 12. Then adding it to the current row 2, 3, 12, 18. Oh, sorry. It should have been a -3 row 1. Like that. These will cancel and make the 0 that I want. 6, 6. Now this is my new row 2. So row 1 is still 1, 2, 4. All right, now you still want to get this to say 0 and this to say 1. Doesn't matter which one you do first. I'm going to do the 0, 6, 6 first, actually. I'm going to do row 2 divided by 6 written in the row 2 spot. So I'm not changing row 1 at all. 1, 2, 4. Row 2, I'm dividing by 6. So 0, 1, 1. And I'm almost there. I just need to make this say 0. So what if this said -2 and then I added it? Then it would be 0, right? So it's going to be -2 times row 2 added with row 1, write it in row 1. So let me do it off to the side. Here's the -2 row 2. 0, -2, -2. Add it with the current row 1, 1, 2, 4. It's going to give me 1, 0, 2. That's my new row 1. 1, 0, 2. Then the old row 2 was 0, 1, 1. And once you get this right here, you're good to go. And the top number is your x, the bottom number is your y. So my answer here is 2, 1. I know, all that work just for that. Okay, let's look at another one of these. This time, they did not give you a matrix, so make your own. -2, 4, -22, 3, -9, 45. Just like that. All right, so make this say 1, 0, 0, 1, just like last time. To do this, I'm going to start with this guy right here, and I'm going to make him say 1. So I'm just going to do, here's row 1, here's row 2. I'm going to do row 1 divided by -2 and write it in the row 1 spot. So that would be 1, -2, 11. I just divided this by everything by -2. Row 2 did not change. All right, next, I want to get this to say 0 here. So I'm thinking, what if this said -3? Then it would work. So I'm going to do -3 times row 1, add it with row 2, and write it in the row 2 spot. So row 1 is not going to change. 1, -2, 11. And then I'll write it off to the side. -3R1 would look like this. And you're adding it with row 2. 0, -3, 12 is my new row 2. All right. Now I need this part here to say 0 and 1. Doesn't matter which one you do first. I'm going to go with this one right here. I'm just going to divide it by -3. That's the easiest way to do it. So I'm going to do row 2 divided by -3. And I'm going to rewrite that in the row 2 spot. So row 1 again did not change. 1, -2, 11. Row 2, I'm just going to divide everything by -3. All right. Now my last move here, I need to make this say 0. So I'm thinking, what if this said +2 and then I added it? Then it would be 0, right? So you're going to do 2 times, I want this to say +2 right here. So I'm going to do 2 times row 2, add it with row 1, and rewrite it in the row 1 spot. So here's the 2 times row 2, 0, 2, -8. Add it with the current row 1, 1, -2, 11. See what you get? You get 1, 0, 3. That's my new row 1, 1, 0, 3. And then row 2 didn't change. It was 0, 1, -4. So this is, I'm ready to basically have my answer. The top one's the x, the bottom one is the y. So my answer here is 3, -4. Okay, last page. These first ones, they just want you to perform a row operation. So row 1 plus row 2 and rewrite it in the row 2 spot. So here's row 1, here's row 2, here's row 3. Row 1 is 3, 7, 2, -1. Added with row 2 is 0, 1, 4, 6. So you get 3, 8, 6, 5. This is your new row 2. Nothing else changed. So my answer here, 3, 7, 2, -1. Row 1 did not change. Row 2 is now 3, 8, 6, 5. Then row 3 did not change. 1, -2, 5, -3. Just like that. Okay, this next one, they want you to do 2 times row 3 plus 3 times R1, and then rewrite it in R1. So 2 times row 3, 2 times everything here is going to be 2, -4, 10, -6. Plus 3 times row 1, so 3 times everything here is going to be 9, 21, 6, -3. I want you to add those together, 11, 17, 16, -9, and then rewrite this as row 1. So this is my new row 1. Everything else is the same. Just like that. Okay, find the solution to the system and they give you a matrix. You want this to say, these are tough because you could either do it as a matrix or you could do it as equations. I'm probably actually going to do these as equations. I'm going to write them out. Well, okay, if you do it as a matrix, you want it to say 1, 0, 0, 0, 1, 0, 0, 0, 1. There's a lot of elimination that you have to do there and a lot of ways that you can mess it up. So I would not recommend doing Gaussian elimination there. I would just write equations from this. So like 1x plus 2y minus 3z equals 11. 3y plus 1z equals 8. And then 4z equals -4. Now I'd just go solve this system. We did one just like this already, but basically they're giving you z right here because you just divide by 4, so you know z is -1. Once you know that, you can plug it in to the next equation above it and just go like 3y plus 1 times z equals 8. Divide by 3. Now you know y is 3. And then once you know that, well, you can just go to the top equation and plug it in for y and z. So it'd look like this. Y was 3. Z is -1. Now just go solve it. The -3, -1 turns into a +3. Now I know x is 2. Once I know that, your answer is an xyz coordinate. So 2, 3, -1. Just like that. Okay, now saving the best for last. Write a quadratic equation that goes through these given points. You need to know that you have your equation, which is y equals ax squared plus bx plus c. But again, you're not going to use that. You're going to use it kind of backwards. Ax squared plus bx plus c equals y. And you're going to make x and y coordinates out of these things and plug them in for the letter x and y in your equation. And you're going to make 3 equations out of this. So here's what it's going to look like. You've got a times x squared. So that's a times 3 squared plus b times 3 plus c equals a y value of 20. Then do it again for the other 2 coordinates. So a times -1 squared plus b times -1 plus c equals -4. And a times -5 squared plus b times -5 plus c equals +4. All right, now you are going to want to square these and rewrite this equation. So like 3 squared is 9. So this part's going to become 9a. So I'm going to do that for all these. Okay, and now once you're here, it's just a system of 3 equations like we've done before. Basically, choose a letter to eliminate twice. I don't say always, I generally will go with C unless there's something just really obvious, but that's rarely the case. So to do this, I need one of these to say -c. It would make my life a lot easier. So I'm going to scale this top equation by a -1. This is my new equation that I'm going to be using. So here's my equation 1, here's my equation 2, here's my equation 3. To eliminate C the first time, I'm going to do equation 1 plus equation 2. So that's going to look like this. Plus equation 2. Add them together. All right, there we go. I got one. I eliminated the letter C one time. Now I need to do it again. So I'm going to do equation 1 plus equation 3 this time. So it's going to look like this. Add them together. Okay. Now that I'm here, I'm going to go vertical with these equations. All right, now you stack them vertical because you're going to have to do elimination one more time. It doesn't matter which letter you eliminate. I'm going to eliminate A. All I have to do is times equation, the top one by 2. because then it would say minus 16, which would cancel with the plus 16. So that's going to look like this. The bottom equation didn't change. Add them together. Divide by negative 16, you get b equals 4. Once you know that, you can plug it into either of these equations. I'm going to go with the one on the right. Doesn't matter though. So it looks like this. Add 32. Divide by 16. So now I know a is 1. Once I know a is 1, I go back to any of these original red equations. I'm going to use the top one. It doesn't matter. I generally go with the one with the lowest numbers, but it really doesn't matter. So I'm just going to use the top one. So that would look like this. 9a plus 3b plus c equals 20. Now just multiply it out and go solve. Whoops. Subtract 21. Once I know ABC, your answer is an equation. So you go plug it into this right here. So it looked like this. Y equals ax squared plus bx plus c. Just like that. So I hope this video helped.